what biogas is.
Our country, for example, India, we are fully dependent on natural gas import. So, government of India has a target to reduce this import. We have the potential to produce enough biogas, which can ultimately replace this natural gas import.
As an alternative to CNG. That is why it is called CBG, compressed biogas. It's a renewable alternative to CNG.
Government of India initially had a target of setting up 5,000 CBG plant across India by 2023, I think. Government of India has given another incentive. They have involved all our oil marketing companies like IOCL, BPCL, HPCL, GAIL. So 56 rupees per kg of CBG. So now they have further changed it, and now they have linked it to pricing of natural gas.
Welcome back to another amazing episode of the Clampreneur Show. This episode is in collaboration with CSIR, Indian Institute of Petroleum. In this collaboration, you would see a series of 8 episodes featuring eminent scientists from CSIR IIP who are actively working to build an Atmanirbhar Bharat while decarbonizing India's energy footprint. On today's episode, we are speaking with Dr. Soumen and Dr. Swapnil on biogas. Why is biogas increasingly gaining momentum in India's renewable energy basket? Why is biogas a prominent future fuel? On this episode, let's break down everything. I hope you enjoy the conversation, and while you do that, please don't forget to hit the subscribe button. Welcome Dr. Swapnil and Dr. Soumen on the Clampreneur Show. So I was just reading about a technology, and we just had a discussion about that, how you're actually upgrading the biogas to, raw biogas to pipeline quality. So before we actually go into the technology, I really want to understand from you that let's first break down what biogas is and why the technology that you are creating is relevant at this point of time.
So biogas is basically a complex gas mixture consisting of carbon dioxide, methane, hydrogen sulphide, moisture. Basically, these 4 are the principal content, but there could be some minor contaminants also. But let's focus on these 4. Out of these 4, the major components are CO2 and methane, almost in 1:1 ratio. Not exactly. I mean, let's say CO2 content is around 40 to 45%, and balance is methane mainly. Hydrogen sulphide can vary from ppm, 500 ppm to let's say up to 3%. It all depends on from which source we are producing this raw biogas, and this raw biogas is produced by anaerobic decomposition of organic matter. Okay, under air-free or under oxygen-free condition, under a closed system, there are classes of organism, bacteria. We call them anaerobic bacteria. They decompose these complex organic materials that can be carbohydrate, that can be protein, can be fat. So ultimately, they convert them to this type of gas mixture. Okay, so there are environmental angle to that. If we, as you know, in India, many these municipal solid wastes, okay, they are not properly. Nowadays, these awareness has come. Now they are getting segregated, and people are generating. Industries are also generating biogas out of that. But earlier, it used to rot in the environment. So in that process, it was basically they are producing methane. Okay, so methane is a potent greenhouse gas. If you see the greenhouse gas potential of methane, it is actually more harmful than carbon dioxide. Carbon dioxide is more talked about greenhouse gas. Everybody knows about carbon dioxide, but methane is another deadly component for increasing Earth's temperature by greenhouse gas. So the greenhouse gas potential of methane but methane has on advantage than carbon dioxide is that it has low residence time in atmosphere compared to carbon dioxide. So it has a typically 12 years lifetime. So, but if we compare the greenhouse gas potential of methane vis-a-vis carbon dioxide, so for a 20 years period, the greenhouse gas potential of methane is around 84 times that of carbon dioxide. Okay, and similarly for 100 years time comparison, the greenhouse gas potential of methane will be around 25 to 27 times that of carbon dioxide. So methane has huge greenhouse gas potential. And also methane, this is the negative side of methane, but the positive side is that it has calorific value. So we can use it as a fuel. Okay, so in that context, we can use biogas as a renewable fuel. So our country, for example, India, we are fully dependent on natural gas import, hugely dependent on natural gas import. Okay, so government of India has a target to reduce this import by indigenous sources, from indigenous sources. So this biogas could be one potential area where we can actually replace this. We have the potential to produce enough biogas which can ultimately replace this natural gas import completely. Okay, provided we meet, there are several challenges that if we can meet that, then it is possible. Theoretically, it is possible.
Why do you think that we have that kind of potential, like coming to you, Dr. Swapnil, to, completely eliminate the imports for natural gas?
You see, biogas is pretty versatile. I say versatile in the sense that whenever there is a a waste of biological origin, the nature has its own mechanism to reduce that biomass and also gives something more valuable in return. We have got a very large agricultural sector. It produces huge volumes of what we call as agricultural waste, which are in some cases are nuisance to the society and environment. As in case of Parali, you might have heard, Parali in some of our states is generated in so much volume that disposal of that Parali is quite challenging from both economical as well as environmental point of view. So this is where the anaerobic digestion can come in handy. In fact, there are many number of plants are coming up in the state of Punjab, where they are converting the Parali, which is a nuisance, into useful resources like methane. The secondary advantage, of course, this is nature's way of doing things. It always optimizes whatever is at the disposal. The secondary waste is after the anaerobic digestion is called a biomanure, which again is literally organic fertilizer for your fields. Parali was one thing. We also have a very big sugar industry. Waste from this industry has also very large potential for generation of biogas. We also have our household waste. You think of any biological waste and it can go to the production of biogas. That is why what Dr. Somen said is true, because if we use our waste, we can convert it to not only a renewable source of energy, but at the same time we can actually reduce our forex burden. Of course, as has been mentioned, there are technical challenges which each feedstock for biomethanation or anaerobic digestion will require a unique set of microbes to cope up with whatever there is in the waste. But then this is what we do actually. Different researchers from different walks of or fields come together and find an optimal.
Another challenge is this related to the logistic of gathering this raw material and bringing it to the digester, because once we start these digesters, it's not possible that someday we'll feed them and other day will not. So then the entire bacterial population will die. So the feeding to the digester has to be constant. So there should be a constant source of once you start a CBG project, So you'll put big biodigesters. Okay, so once this organisms will start producing this biogas, then they need constant feeding. So that constant feeding means constant sourcing of the raw material. So until and unless you first work out, ensure continuous and supply of this raw material, organic waste, and their required pre-processing. So until and unless you ensure that, then otherwise it will be problematic. You see, understand? So first, so this is basically logistical issue.
But when we have like so much waste, why is this like issue coming in?
I mean, there are like municipal solid waste, for example. Okay, so if you are generating biogas from municipal solid waste, so the problem is majority of municipal solid waste are not properly segregated in India. The organic contents are not segregated. So you have to collect enough waste, and then you have to have this sorting and segregation facility. Okay, so then you put it into digester. So likewise, there are challenge for different feedstock. There are different challenges, but it's not that they are not surmountable. Of course, it's possible, and towards that, already many companies are now upcoming in India. So who are coming in a big way for producing CBG. So there are challenges if you recognize that the typical challenges for each, like in Parali, for example. So Parali has challenges of its pre-processing. Okay, it is a lignin-based organic waste. So if you do not manage this lignin content properly, so ultimately what will happen is that they will not get what you are the based on which you will design your biodigester, you may not get that kind of yield. Okay, typically 1 ton of Parali theoretically can generate 250 meter cube of 250 to 300 meter cube of raw biogas. But if you do not process that Parali, pre-process it properly, so you may not get that kind of yield, and also there is a hazard of choking up the biodigester by lignin.
What happens? This Parali is what we would call technically as lignocellulosic biomass. There is cellulose and there is lignin. Lignin is a natural chemical which protects your biomass. It makes it hard. The problem is that lignin is harder to digest by those microbes. So, but at the microbe has to reach the cellulosic part. So the pre-processing is required so that it is either pre-cooked or shredded to very small size so that the cellulosic part is reachable by the microbes. So these are the challenges. I mean, other biomass have their own set of challenges, like the biomass that Dr. Soven earlier mentioned, press mud. It is a byproduct of sugar baking. It has large amount of sulfur. So when you convert it to biogas, your biogas will have a very large amount of hydrogen sulphide. Which is in turn is harmful to your process equipment, pipelines, everything. So that is another challenge to mitigate. So, but of course, technological solutions are available for all these challenges.
So, let's discuss about your technology now. That why do you think that we need to convert the raw biogas to pipeline quality gas?
First of all, as Dr. Somen said, there are 4 main constituents of biogas. One is methane, the most desirable, because it burns, it has got calorific value. Then there is CO2, which again it doesn't burn, but it makes up to 40 or 45% of your total biogas production. So if you have to transport your biogas or compress it, you will be compressing this 45% of CO2 which is not needed. So removal of this CO2 at the point of production is logical. The rest of the 2 components are moisture and hydrogen sulphide, which together are a deadly combination because they cause corrosion in your pipelines, in your gas engines, etc. That is why Government of India, or rather the Bureau of Indian Standards, BIS, has given a specification which is called BIS 16087. It was introduced in 2013 and it was later modified. So it says that for pipeline application, your compressed biogas or biomethane shall have minimum 90% of methane, not greater than 4% of CO2, less than 0.5% of oxygen, less than 20% of 20 ppm, that is parts per million of hydrogen sulfide, and less than 5 parts per million of moisture. That kind of stringent spec is there, and that is why technology like ours are required, so as to remove CO2, hydrogen sulfide and moisture from your biogas, so that it can be used industrially, reliably and safely, either as a cooking fuel or as a vehicular fuel. So whenever we put in a large systematic, applications like as an alternative to CNG, that is why it is called CBG, compressed biogas. It's a renewable alternative to CNG. Then we have to have the same kind of safety standards. Speaking of our technology has been tailor-made to the requirement of raw biogas. When the raw biogas is produced, the inherent pressure is not very great. It is hardly little above the atmospheric pressure. So we designed our technology so as to keep our operating pressures as close to atmospheric pressure as possible. So we do not expend extra energy to run our purification system. Otherwise, if you are using more energy, then the net output of energy will be less. Of course, after purification, you have to compress it to make it suitable to put in your CNG or CNG equivalent vehicles.
In fact, just to add on, there are two end use. One is as a replacement of piped natural gas. Okay, so if you want to use as a piped natural gas, then CO2 content, CO2 content should be less than 10%. Okay, the methane content should be 90% plus. But stringent specification of CO2 is there when you intend to use this gas as a vehicular fuel, means CNG equivalent fuel. So then it's more stringent. The CO2 content has to be less than 4%. Otherwise, what happens, because you are going to pressurize it, as he was saying, to 250 bar, okay, in cylinders, 250 bar high pressure. So if the CO2 content is more than 4%, what will happen when you release that high pressure gas to your engine, internal combustion engine? So during that process, due to Joule-Thomson effect, there dry ice formation will take place. So that will choke all the
nozzles and
valves. So that's why it's more stringent when you intend to use that gas as a vehicular fuel.
By when say can we completely swap the CNG with CBG?
Well, technologically we are ready.
What's stopping us?
The implementation under the government's Satat scheme is currently at very earlier stages. There are only around 40 odd plants which are operational.
So I can say like this: Government of India initially had a target of setting up 5,000 CBG plant across India by 2023, I think. Am I right? So far only 50 plants has been established. So you can see there is still a huge gap to before you can say that yes, we are close to the target.
And one of the plant is again factor is again the continuous availability of feedstock.
Feedstock, yeah.
Because if you say in case of Parali, there is a certain period of time when the Parali is available. If you want to run just your biogas plant on based on Parali, you have to have a large space just to keep your inventory. Then, which at most of the times is not possible. So you look for other reliable sources, like say cow dung. Now your that bacteria has to be designed such that it can digest cow dung as well as Parali. So these are the operational challenges. I will not say these are technological challenges, but industry being new, what I feel, it's my personal view that most of the players are not still very well versed or experienced in all these operational nitty-gritties.
It's a new space right now.
And if say one player is facing difficulty, the other players are already alarmed that okay, he is facing the difficulty. It is not the technology. It is just that there is no, there is not a I would call a critical mass of these plants or operators which are experienced enough who can do the understand the nitty-gritties and make the adjustment.
Do you think that's something of that kind? For example, if we have a biogas plant, specific to each state, like every state would have their own set of wastes coming in. So probably something that is specific to, geographical location. That could be like an area that probably we could look on. So the supply chain gets fixed and
in fact, it is happening in most of the cases. Government at policy level and at state levels have been very active, not only in making the policy to see how it is being actually implemented. So these kind of changes at district levels or they are being implemented.
Now, Government of India has given another incentive. They have involved all our oil marketing companies like IOCL, BPCL, HPCL, GAIL. So, all they have Government of India has instructed them. If any CBG producer, private CBG producer, can provide a required amount of CBG per day, so they have fixed the pricing. So initially they are saying that you are guaranteed a price of 46 rupees, okay, 46 rupees per kg of CBG. So now they have further changed it, and now they have linked it to the day-to-day this pricing of natural gas. They have linked it to natural gas price. So they have upgraded the pricing also. So this is also one of the incentive to the CBG producing companies. So if you can generate, they have set up a limit. If you, the quantity should be minimum 2 tons per day, 2000 kg per day of CBG. If you can generate that kind of CBG, then you can approach an oil marketing company. They will guarantee the uptake.
They'll buy that kind of CBG from you.
So would you say that we are on a good track and India would see that?
Definitely. The kind of ambitious commitments we are making in terms of reducing our greenhouse emissions, India has to lead actually. It is not that we are very large emitters of CO2 per capita, at least per capita wise, but it is very good that Government of India has shown very serious commitments to reduce, and despite not being a developed country, so it is a way we are showing the torch to the
actually the fact is that if you don't do that, the full brunt of global warming is going to come to us only, because we will be the worst sufferer. Although we are not responsible for the current situation, but still we have to face the music.
We are the most vulnerable in times of.
And that is there, I really appreciate what Government of India and specifically our Honorable Prime Minister Narendra Modi ji is doing, even with the coming of the India Energy Week. I think it's a great initiative to put India on the global map. And as I feel that, somewhere he also and the entire body gets confidence from people like you, because who are working so actively in decarbonizing India's energy footprint while providing the access and security to energy. So thank you for doing that, and thank you for saying it with that confidence that India has to lead. Thank you for being with us today here.
Thank you.
Thank you, ma'am.
Thank you so much.